The purpose of this video is to teach about how to do regressions with a data set. This data set is about physician assistants. It's going to examine whether things like their GPA and their GRE scores are going to influence an important test they take called the PANCE test that is needed for them to become physician assistants. So I have my data here in Excel. I have the following variables: first name, last name, gender, undergrad GPA, GRE score percentile, whether they passed or failed their anatomy class, the caliber of their undergraduate institution, and the PANCE score. The PANCE test is an important test that physician assistants take. So when I have this Excel data, the first thing I would do is make sure that this is all of my data. If this is just the data from 2019 and I have years back, I would copy paste all of the data into the same sheet so we can analyze it all together to get the maximum amount of statistical power possible. The next thing I'm going to do is called cleaning my data. First, I'm going to give everybody something called a subject number. That will help us know who's who is in the data set. So I'm going to insert a column here, and I'm going to call this subject number. And what I'm going to do is just assign a number to each person. Since this data set is about physician assistants, I'm just going to say PA1, PA2, PA4, etc. Now everybody has a subject number. That helps us statistically. You don't have to have it, but it can be helpful. Then I'm going to turn any variables that are words into numbers if I'm going to be using them in analysis. First name and last name, that's not going to be part of my analysis, so I don't have to worry about that. But now let's next look at gender. We have male, female, and other, and so we're just going to assign a number to each of those. I'm going to start a tab in the spreadsheet that I'm going to call my code book, where I'm going to say what all the numbers mean. So let's start there. New sheet, code book. Let's call the old sheet data. And so we're in the code book, and I'm just going to say gender. And these are the numbers I'm going to use. 1 equals male, 2 equals female, 3 equals other. Okay. So now let's take the data and assign those numbers. So to do this, I do this in a way that might be a little bit different than some other people, but what I like to do is I like to copy the row, paste it in another spreadsheet tab, and then I'm going to do Control Find, and I'm going to do a Find and Replace. And if it's F, I'm going to replace that with a 2. And then if it's M, I'm going to replace that with a 1. This data set didn't have any other gender identities in it. Now we've got it how we want it. So let's put that back into the original spreadsheet. Cool. So now we've got gender numerically. That's awesome. Undergrad GPA and GRE percentile were already numeric. Then let's do the same thing with this variable. It's about whether they passed or failed their anatomy class. So what we're going to do is same thing. Let's take this row and we'll put it in this data sheet where we're cleaning stuff. I'm going to go ahead and delete out this one because we don't need that anymore. Let's go to our code book, and I'll say anatomy, pass, fail. And let's say 1 equals pass and 0 equals fail. Cool. So let's go ahead and change those here. We're going to do find and replace, and this time we're going to say let's replace all the P's with 1s. Cool, and let's replace all the F's with 0. Awesome, okay. So let's take that again and put it back. Oh, I guess I have a typo on that variable, I'll have to fix that. Anatomy, pass or fail. Oh, I know what happened. When I did the find and replace, it changed the letter, so sometimes you have to be careful about that. I took the P and it turned it into a 1. I took the F and it turned it into a 0. So just watch out for that. That's why I do it on one variable at a time. Otherwise, you could accidentally assign stuff to other variables that you didn't really need to. The last one that we have to clean up like this is undergrad school caliber. This is kind of about what type of school that they want to for their undergrad institution and how it was ranked, maybe in like the US and World Reports rating or something like that. So we've got high, medium, and low. I'm going to copy this into our other sheet. And we don't need this part anymore. Then I'm going to put this in our code book. What was that called again? Undergrad school caliber. And we're going to say 1, 2, 3. High, medium, low. Cool. And we'll do our find and replace again. This time we're putting in a whole word. Find the word high, replace it with 1. It didn't like that. Oh, it's because I highlighted those cells. Try that again. Okay. Then we're going to do medium and replace it with 2. Okay. And then we'll get that low and replace it with 3. Awesome. Okay. We're going to copy paste that back in. And a lot of times you want to retain a copy of the data before you ever did any of this stuff. That way, if you were to ever worry that you made a mistake, you could go back to the original data, make sure that you didn't make a mistake in this phase. So for this example, I didn't actually save the sample data, but that's what I would normally be doing. So let's go ahead and save this, and then we want to get it into SPSS. SPSS is just going to put in the first page of this. So what I'm going to do is open SPSS. Okay, it's going to take a minute to open. Just thinking about it. All right. And when we get this menu, we're just going to close it. Now in SPSS, we have 2 views, the data view and the variable view. Let's go into the data view. And I'm going to go to File, Import Data, and in this case, I'm importing from Excel. So I'll click on that. And then I'm going to go into my desktop where I saved this data. I don't really see it there. Maybe it's here. Where is this data? Let's open back up the Excel. File, Save As. Oh, it looks like it was in my documents. I wanted it to be on the desktop. So let's do that. Okay. Try that again. File, Import Data, Excel. And now let's go to the desktop where it should now be. Cool, awesome. So we're going to click Open. And you can kind of see on the bottom of the screen it says Excel ... It's trying to get it. So I just use the default settings on this. I don't really check off anything other than what you see here. The only part that's really that important is read variable names from first row of data. This will help you, it will make your life easier because it will go ahead and put those first rows as your data names, so you don't have to put those in the variable view. So that's kind of cool. I'm going to say OK. And it minimizes for a second when it does this. I don't know why, but then here we've got everything we wanted. And you can see I have variables that were more than one word, and it just concatenated them into one word, or sometimes I feel like it will put it in underscore. So that's cool. So we have everything we want. We're looking at it in the data view. Let's look at the variable view. So here we have all of our variables listed in this column. And then we want to tell SPSS what type of variable each of these things are. A string variable means it's just a word. It's not like a category. It's literally just a word like their name. The subject number is always a string. The name is going to be a string. And then we have other options for the other variables, and they're generally just going to be a number, numeric variable. Width is not important. Decimals would just be like when you're viewing the data, if you prefer to see a certain number of decimals, you can change that. Not really that important. And then we've got what we would see in the output as a variable name. That's a label. So somehow gender didn't get copied, so I'm going to add that. And so just if you don't have anything here, it's your choice, but you could go ahead and add that label. But the next part is the values, and that can be important. That's where you'll put in your codebook information on what different values meant. So let's do gender. We're going to click, let me show that again. We just kind of clicked in the right corner and we saw this ... thing. So you kind of click and you see that. And I'm going to put the value is the number that's associated with it. And I think we said males were 1, females were 2, and other was 3. So I'm going to put 1, and I'm going to type in males, and then I'm going to click add. And let's do that with the other gender categories here. Cool, and then I have to click OK at the end. This is going to make our output come out where it tells us who's who. We don't have to do that for GPA, it's not categorical. We don't have to do that for GRE score, it's not categorical. But for anatomy, pass or fail, I think we said 1 was pass and 0 was fail. Alright. And undergrad school caliber, we said 1 was high, 2 was going to be medium. I've actually removed it. Sorry about that. Okay, 2 is going to be medium. And 3 is going to be low. Add. Okay. And then the last thing we want to look at is the measures. And so we want to say it's nominal if it's a categorical variable, and we want to say it's scale if it's a continuous variable. So subject number, that's obviously not a scale. First name, last name, not a scale. Gender is nominal, so although it is listed by numbers, it's categories. So that's why we would say it's nominal. Whereas undergrad GPA is scale. Basically, if the number is meaningful, like a higher number has some sort of significance other than just labeling it, that would be a scale variable or continuous variable. So we've got scale for these two right here. Then anatomy, pass or fail, that's nominal. Undergrad school caliber. You could think of this one as nominal or scale. If you want to think of it as a continuum, like the better the undergrad school is, the different kinds of effects you'll see, you could say that it was a scale. If you just want to say these are categories, but we don't really think they're quite continuous, we could say they're nominal. I'm going to go ahead and leave it as nominal because I think these aren't exact continuums, and so I would kind of treat it as nominal. And finally, we've got this PANCE score, which was an important exam score. So let's go back to the data view. So before we even think about doing a regression, I want to show how to do a correlation, because you never want to put in more than 4 or 5 variables in a regression most of the time, maybe like 3 or 4. You don't want to put too many things in one regression, because then it's hard to make heads or tails of what's causing an effect. So if you were going to be running a lot of tests, you might be better off to run some correlation. So let's just show how to do that. And let me back up for a second. Before we even do that, let's talk about how to get some descriptive information from your data. So let's say I want to know what was the mean undergrad GPA. What I'll do is I'll go to Analyze, Descriptive Statistics, and then I can do frequency or descriptives. For the mean GPA, it's going to be a descriptive. It's descriptive for continuous variables, and you would want to use frequencies for categorical variables. So first, let's do this descriptive. Let's get the mean GPA. So I'm going to click on the variable I want, and I'm going to click this arrow, and it puts it on this side. And I can look at these options if I want to. Yeah, I want the mean, the standard deviation, the min, and the max. I think that's all I really care about, so I'm going to say okay. And let's see what we get here. Okay, cool. So what this shows us is that the mean GPA was 3.467, and then here's the standard deviation right here. Now let's show frequency. Analyze, Descriptive Statistics, Frequencies, and let's see what the gender distribution was. So I'm going to slide this over here. Do I want any statistics on it, like a chi-square test or something? Nope, I don't care. Do I want a chart? I guess I'll take it. But you can kind of mess around with this, but you don't really have to click on any of this stuff. You can just say okay. And so here we show our gender distribution. We have 4 males and 5 females, and it made us this is a really big bar graph actually of gender. Okay, so we kind of get our information here, so that's really cool. So now let's talk about a correlation. So let's say we think that your undergrad GPA is going to be correlated with your PANCE score. So we would say Analyze, Correlate, and these are going to be bivariate correlations. That's the most typical kind of correlation you'll be doing. And so we're going to say the 2 variables we want are undergrad GPA and PANCE scores. We want to do a Pearson correlation. That's what's appropriate in most situations. We want to flag significant correlations so we know if the correlation is significant. We almost always want to do a 2-tailed test. A 1-tailed test means that you're expecting some sort of directionality, but a 2-tailed test is more conservative, and so it's usually better to use for that reason. And we can look at the options if we want, but I didn't really want any of these options, so I'm just going to close it out, and I'm going to say okay. And here we have our correlation. So we see undergrad GPA is correlated to PANCE score, and then we see the reverse of the same thing right here. It's kind of like a repetitive matrix. The correlation coefficient is that top row, this number right here. 0.118 is the correlation coefficient. And then here we see kind of the more interesting part, whether it was significant. And in this data set, which is a fictitious data set I just made up for this demonstration, we don't see any significance here. If this number, which is the p-value, was less than 0.05, then we would say this was a significant correlation. But the p-value is 0.762, so that's not significant. So this would tell us these 2 things are not significantly correlated in the data. But now let's get to the exciting part, which is regressions. So let's say we want to think that 2 or more variables are affecting some sort of outcome. We can even see how they might interact with each other, but that's a little bit more advanced. But it's definitely something that we can do. But for the purpose of this video, I'm just going to show a regression with 2 or 3 predictors on an outcome. So to do the regression, we're going to say analyze regression, and these would be linear regressions. So we're just going to click on linear. And so we'll put our independent variables, or our predictors, here, and they can be continuous or categorical, doesn't matter. So I'm going to put in gender, undergrad GPA, and GRE score, and whether you passed or failed anatomy. And I really wouldn't put like more things than this in one regression. I would suggest to run multiple regressions to answer different research questions. But let's just go ahead and put all this stuff in this regression. The outcome variable, or the dependent variable, is going to be the PANCE score on that exam. And we can look and see if there's anything special we want to click here. I like to get the R-squared change. That's interesting to me. It's more interesting when you're doing a hierarchical regression with 2 steps, and that's a little bit more of an advanced skill, but it's something that you can learn how to do, but it's still interesting to know. And sometimes we want to get these collinearity diagnostics, so let's go ahead and get that. But I think that's all I want for now, so I'll just say okay. And it has options to make plots, but I don't really like these kind of plots that it makes. They're not really that useful to me, so I'm just going to ignore that. There's different options, but I'm just going to ignore that. So there's different things you can play around with, which is kind of cool. Then you say okay. And so it's kind of confusing because a lot of output comes out. This part right here you don't really care about, just ignore it. If you're interested in R-squared change, this is where you'll find it, but that's a little bit beyond the scope of this video. This ANOVA, you'll just totally ignore. And here at the bottom, the collinearity diagnostics, that's a little bit beyond the scope of this video too. What it's telling you is how correlated your variables are to each other, and if the regression can tolerate that. So let's just ignore that for now, but we can maybe cover it at a different time, and you also see those over here. But let's focus on this right here. This is the output of your regression, and we can see if any of these factors were significantly predicting the PANCE score. So this SIG column here, this is where the p-values are. First, you have the p-value for the constant. You can just ignore the constant. It's the y-intercept in your regression, and it's just not relevant to the most common research questions, so it's like you just totally ignore the top row, don't worry about it. But the bottom 4 rows are for your different variables, and what you see here is that none of these variables were significantly predicting the PANCE score, probably because I just made up this data set. But if they were less than 0.05, then they would be significantly showing this PANCE score. The T statistic is here. That's something you report. Degrees of freedom are here. You can get them from the ANOVA, so I guess it's not true to totally ignore the ANOVA, because you can get degrees of freedom there, but degrees of freedom are usually your n minus the number of variables that you put into your regression. Some people, when they're reporting a regression, report the t-value and the degrees of freedom. That's what I used to do. Now I actually report the standard error instead. That can be a little bit more helpful to some type of researchers, so it's right here. It's just something I would report. And then the B helps you understand how your independent variable and dependent variable relate to each other. This is kind of like a magnitude measure, and so that's kind of neat. It tells you kind of how big of an effect the factor is having on the dependent variable. So that's kind of neat. Before I show you how to write this up, let's just talk about how to make a simple graph in SPSS. A lot of times they're not pretty enough for like a report or something, and you might just take your data into Excel and make a graph in there, but it's still cool to look at. So let's make one here. I'm going to go to Graphs, Chart Builder, and say OK. And here I want to make a scatter plot with a regression line. So I went to Scatter, and then I picked the one with the line. So that's kind of cool. I pop that in here. And my dependent variable is going to be the PANSS score. But let's say I want to say my undergraduate GPA is the independent variable here. And I'm just going to say OK. Let's see what comes out. Cool. So basically, in this fictitious example, we're showing that even though it's not significant, a higher GPA is associated with a higher PANSS score because the slope of this line is positive. So that kind of makes sense. When you're working with humans, you expect there to be a ton of variability because everybody is different. So that's why the dots are so far away from the line. That's very normal for working with humans. It's a little different if you're working with like a bacteria or something like that. But I'm a psychologist, so I work with humans, so this is how my data would normally look like. So how do we write up the results of the regression? So I'm going to open up a Word document to show that. And so let's see. So let's say we want to report on the effect of undergrad GPA on the PANSS score. Now, when you're reporting a regression, you can report on all the variables that were in it. That's what I prefer. You can report on just a significant variable. You can report on just a variable you personally really care about. Doesn't really matter. It's up to you and the purpose of what you're doing. But let's say, okay, undergraduate GPA was not significant. I'm struggling. Significantly associated with PANSS scores. And then I'm going to report the B statistic here. So here's negative 13.79. So I'm going to say italicized B equals negative 13.79. And then I'm going to say SE, standard error, italicize that, is going to be 24.87. And then I'm going to say the p-value, remember the p-value is the sig part. I'm going to say p equals 0.609. And I got to italicize the p. And so that's how you would write it up. Like I said, you could have written it up with the t-value and the degrees of freedom in lieu of the standard error. It doesn't really matter. Both are super acceptable. And then you can make a better looking graph of this in Excel. Let's see if we still have that open. So what were we doing? Undergrad GPA and PANSS score. So I'm going to make a new tab for my graphs here. Got undergrad GPA, got the PANSS score. Oh wait, that's not what I wanted. Oh, here we go, okay. PANSS score, and let's just kind of lasso it. Go insert a chart. Let's do a scatter plot. It just looks like a little scatter plot here. Cool, so here's our data. And then let's put in a regression line. Well, I didn't mean to change the format of that, but I kind of like it. But then we'll just go to quick layout and see this one with the line. That's what we kind of wanted to see. And so it's kind of showing the slope here of it's really zoomed out, but the GPA and the PANSS score, if we wanted to kind of zoom it in, we double click on that. Let's click on size and properties. Or wait, that's not it. Sorry about that. Let's click on the axis, and then we'll click on this little bar graph thing, and let's make this a little bit smaller because the test only goes up to 100 and nobody got less than a 60. So I'm going to do it like this. Let's do the same thing with the x-axis. Everybody's GPA was between like 2 and 4. So I'm going to zoom this in a little bit. Awesome. In fact, I think we didn't have anybody above 2.5, so we could just get a little more zoomed in, and we kind of see our effect here. So that's awesome, and we could label the axes and just play around with it and make it however we want to. So that's basically it. That's how you would use regressions in SPSS to analyze your data. So thanks for listening.